So let's wait for some more to come. Should be okay. Everybody in? Should we start? Okay, let's begin. I think we might run out of time. In fact, we wait for more. And as we discussed, today's focus is much more on applications of deep learning on NLP, what is known as natural language processing. So, not go much deep into what is deep learning or what is NLP, but we'll particularly look into the how the different aspects of deep learning impact the NLP, and we'll go through a couple of examples as the focus is on which we'll go through some.
All right.
Things developed already. Examples in and all the and they have some time dedicated for you to ask some questions and all those things. So let's begin.
Ashish, your audio is choppy. It cuts out every once in a while.
Pardon?
Your audio is a little choppy. It's cutting out every once in a while. I lost about 1 out of every 10 words.
Okay. Let's sort out. Now it's okay. It's okay now.
Yeah, can you try saying just a few more words in a row?
Oh, okay. Okay, what I was saying was we'll just quickly go through the different aspects of deep learning and how they particularly impact the natural language processing. We'll not particularly go into what deep learning is or what is what is NLP or something like that. We'll just see. So we'll just have more focus on why we use deep learning for NLP. So going ahead a little bit about me, you can just find it out on my LinkedIn URL here. So I am basically right now on a remote location in India on my farms. So that's the beautiful butterfly there. Okay. So this is the agenda that I have brought in for today. So we'll just quickly go through what is NLP and how it affects, how deep learning affects it, and how what are the different applications of NLP and how deep learning affects it. And we'll quickly go through some demos on ML Studio. So what do you think? Why all these windows are there and everywhere? This is basically what I am trying to express is this deep learning is affecting our computing by and large. In fact, even if we go to or rather NLP, if what so what actually so whatever you take, whether you are going through notifications, whether the Android is or your Windows is processing the notifications, or your what do you call it, assistants, the virtual assistants, what we say, everything is all about NLP. So that's why I just brought in this Windows here. In fact, and this mouse is not working, I guess. Okay, here we go. So what I am trying to will focus is on the modern approach to NLP via deep learning. So in fact, classical deep learning requires quite a bit of experts in language defining rules to cover specific areas, which definitely has changed when in deep learning era. In fact, the statistical methods of NLP improved the classical linguistic methods. Where we went. Okay. But the drawback of this method, what they particularly required was an expert to pitch in to understand the different aspects of linguistic models or the methods, how they impact our statistical models and all. But when the deep learning came into picture, it not only brought the variety, but also also brought the volume to the entire process of natural language processing. So in fact, it gives a much simpler and what we call it as a singular model of for solving NLP. So deep learning methods were never thought of way back in if you take in 90s or something, whether they could have impacted NLP. But in fact, what has happened in 2020, the whole bunch of models is coming like sequence to sequence, or what we know as the role of RNNs and CNNs and all those things. So this particular applications of NLP did involve text classification, speech recognition, or what we call as a time series content analysis, and a couple of other applications as well. So all these applications require kind of volume to the entire process of NLP. It's not like we use NLP for or what you call it, deep learning for one particular to process one particular text block or something like that. It brings a whole lot of data into it, and a variety of data. In fact, it's come from whether it's coming from tweets, whether it's coming from your logs in case of IoT applications, or it's coming from your hardware devices like speakers in case of speech recognition and stuff. In fact, if you look at the time series content analysis, you get a whole lot of multivariate data. That's something really new to the NLP. So we do have certain specialized deep learning frameworks for NLP, like LN framework, which is in fact on top of PyTorch, which focuses on semantic aspects of the NLP task, like labeling or text or co-reference resolutions and all those things. Another one is Open NLP toolkits and which particularly focuses on sequence models and which brings in the applications of sequence to sequence models to tasks like machine to machine translations, in fact. So moving ahead, we'll just go through a couple of definitions or the terms which particularly impact the NLP process. One particular term would be very interesting to note down here is the language modeling. What is language modeling, in fact? Here we try and estimate the relative likelihood of different kind of phrases as they are useful in NLP. So what are we trying to do over here? What we are doing is we're calculating a probability distribution of words. So this was particularly a traditional way to do that. For example, the n-gram model. What n-gram model was typically suggesting was, for let's say we have a single gram or 1 gram. So here what we try to use was we'll try to find out how many times a word or in what particular sequence did this particular word appear. So if we have bigram, we'll try a combination of two words. In fact, if we are trigram, we are trying to relate it to 3 words, combination of 3 words. In fact, this all changed with hidden Markov models. The hidden Markov models did try and modify this entire process and brought in some kind of different artificial intelligence, which was very much similar to what we do today. What they did was it tried to find out value of hidden variable or how the particular hidden variable will affect the observed variable or how the observed variables were affecting this hidden variable. For example, not particular to NLP, but is a very good example to understand here what are hidden Markov models and how they could have played a role in NLP, in fact. So it's like to judge what is the particular weather at particular location by looking at what type of clothes people are wearing. So it's quite a different aspect of it. So what we are trying to do was we are trying to get the probability graphical model to predict a hidden variable. So that all led to the advance of natural language models. Which gradually graduated to neural networks, in fact, the use of neural. So what here we do is we use NLP to get down the different aspects to synthesize all this variety and volume of this textual data or the language data, in fact. So one particular model that neural network you might have heard is convolutional neural network. What here we try to do in CNNs is to convolute the different layers which process that converted data or the vectorized data of this text in text. which is then particularly pooled, and then we form a fully connected neural network, and which the output of which is used in classification. So what we here do is, there's no limit in fact here. What we can see, this is completely a layer-based application now. It's not like one particular process is there or one particular algorithm is there and it runs, and then we begin the process, we end the process, and then probably we get the output. Here there are a series of processes. So that's the beauty of NLP. Sorry, the deep learning now. This was particularly extended later in when RNNs were brought in picture, which were heavily used in NLP. This is now a recurrent neural network. Now the beauty of this is we brought in activation function, which particularly got one input and tried to influence the pooling of the layers in fact. So there is no limit here in case of what kind of variety is coming and what kind of layers we are dealing with and what kind of volumes we are dealing with. In fact, this is all deep learning has brought is the process to NLP is the infinite kind of processing power through layers, which are sometimes convoluted, sometimes recurrent, sometimes we move it into a what the latest one is like. I was going through a couple of days as I go is the circular neural networks. In fact, we are trying to move the entire process in a particular circle. So then we come to the text classification. So what classification what we mean is, let's wait for a while here. Before that, we understand is how the text embeddings are done. So what I am speaking, or what the text we see on the internet or all over, or what kind of the inputs we get from the hardware is all about the human language. And as I said, the layers in the deep learning networks are vectorized. They don't understand, the computer doesn't understand this kind of language what we are speaking in fact. This is what is called as natural language. So we need to get the numerical encoding of this text. This is what exactly happens in the vectorization process. And in fact, you might have heard something like word to vector or doc to vector, or all these expansions of this particular thing. So as we can see on the slide, that some particular human language text is taken, and then it goes to the encoding text, and some kind of magic happens. We'll see what kind of magic it is, and we get the process data. So then we have a feature the word comes as feature extraction. So basically a feature extraction is a process which can be done in two, as we might have studied in the class, is all about the bag of vector kind of processes which are based on TF-IDF. So what we do here, it's all about getting the
Bluetooth device is ready to pair.
Pardon?
Bluetooth device is connected successfully. Device ready to pair. Aux input mode.
Video is cutting, something like that.
Hello, Ashish.
Yeah.
I think you are on a different slide, but we are still seeing your very first slide.
Okay. You want to see the other one?
No, I mean, you appear to be on a different slide, but we are only seeing the first slide, the natural language processing slide. We are not on the same page as you are.
Oh, you are not able to see this the slides, in fact.
Exactly.
Oh, ho, 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 ho. Let me see what has gone wrong. Okay, let's go. What has happened is the slide has gone. This slide layering has stopped in between somewhere. Now it's visible. Hello.
Now
Yeah.
we can see.
Yes, it is.
Now we can see the PowerPoint, but it's not playing as a
Yes.
PowerPoint.
Oh, okay. Now the things should be all right. I'm sorry about it. We'll just quickly go back and see what kind of slides we had. Basically, nothing much here. We are talking about this slide particularly talks about the applications of NLP, and I was talking of how the different uh, different types of data what we get in, and the different kind of volume we get nowadays to deal with. That is all deep learning is bringing to NLP. In fact, the type of applications like speech recognition or the time series content analysis in particular. Don't worry, we'll all go through just one by one in detail in next slides. Okay, then I was talking about this quickly about this natural language models here. This were the statistical language models were the kind of probability distribution based models which I was explaining, in fact, like the ngram, which was dealing with the how the occurrence of this particular sequence of words affects the processing of language. So, for example, n-grams for the once or the single gram did talk of how one particular word occur reoccurring again and again, to what frequency, in what combination, and all that stuff. Then we came about the hidden Markov models, which I was talking about. This was again a very traditional way of doing it. Basically, brought the concept of trying to read a hidden model or a hidden what do you call it, hidden objective inside it, or a hidden label, in fact, trying to predict out all things about it via some kind of observed variable. So that's why the name hidden there. This brought in more intelligence to the system. And then these scientists tried to combine with certain linguistic rules and n-grams and all those things. So they all tried with different variety of things, but it was not bringing the volume to it. So this is what exactly all changed in particular when we arrived. We started using neural networks into the to the NLP. So neural networks, deep learning is all about neural networks. It's all deep by what we mean deep is it's about layers, what I was talking about. Then we talked about what was text embedding. Text embedding is nothing but a kind of process of getting the vectorized representation of human language. So probably computers don't understand, neither the deep learning networks understand what all about the natural language, and it gets so kind of models we get through CNNs and RNNs was through the human was all about getting the vectorized representation of the text, and then some kind of magic, all that happens, and we get the process data. That's what was this slide talking about. So coming back to our feature extraction here. So what we are trying to do is we are trying to understand here what kind of token or what kind of document or what kind of word it is, and how it is affecting our process. For example, what we studied in our class was all about the bag of words, which were depending on the TIF. So that is the TF-IDF, what we are talking about. And the second way of doing it, doing all this, is via the word embedding, like embedding, which were probably derived out of deep learning networks. For example, talk to vec or word to vec or kind of things. So moving ahead, what we see is a kind of what is what we all study was what about TIF and stuff. So let's first understand another term, what is called as text normalization. So what all happens is we are all great to use kind of raw words like numerical 2 and numerical 2 for tomorrow, B4 for before, and all this kind of notations to express smile and all these things. What are known as popularly known as emojis. So all this needs to be normalized for the computer to convert it into a numerical format and some kind of representation we get, what is known as the feature extraction. So this is all about when we see what is the magic what was we were talking about by taking an example of an text classification. This is again taken from our class. In fact, we'll look into a couple of different examples in the demo session. Here we are seeing what we are seeing is there is one deep learning algorithm that has brought in on the right, which is giving us a classification model. So as we all know, classification is all about the supervised machine learning. Machine learning, in fact, and deep learning, in fact, is a specialized case of machine learning itself, wherein we deal more data, we deal with more layered kind of processes. It's not like one single process which comes, which begins, ends, and we evaluate and we go back, check the score, what it is, and then again try and see if all our parameters are correct or not. And this all changes in deep learning. In fact, we can get hundreds of such layers, and the type the way we make these layers interdependent, or what we call is spoon. What makes the different kind of neural networks? For example, convolution makes the convolution neural networks. The recurrent model makes the recurrent neural networks. More recently, if we try to connect all these layers in a circular fashion, in a particular way, so to process all this data, they are called as circular neural networks and whatnot. The different kind of the neural networks have been experimented till date. Coming back to the TIF, in fact, TIF, as we said, was a typical idea to extract the features. So what we were doing is to break down all this particular text in what is in technical language called as tokens. Now, so for example, if we are dealing with a particular text which is particularly large enough to deal so that the deep learning comes into picture, our token is a word. In fact, if we are dealing with in documents, this token becomes the whole set of words, that whole set of document. So what this does, as the name itself suggests, is takes the term frequency and relates it to the idea. We just see what is IDF and how it relates to term frequency, why that hyphen is there in the in middle of that term TF-IDF and all these things. Okay, So talking about the term frequency is all about the token frequency here. So how many times the token appears in this particular data set, and how it is related to each other and all those things. And the IDF, or the inverse document frequency, exactly deals with the number of documents, or the number of documents, or number of combinations of word we are trying to study here. So in case of, if we are dealing with the whole bunch of documents here, we'll see a particular pattern in the way the term frequency and the inverse document frequency is related to each other. So what exactly happens if the token occurs more frequently in a doc, the term frequency will increase. That was what the natural part of it. But the IDF will try and suffer. So what will exactly happen is the term or the token frequency in that particular document will get inversely affected. What does that mean? The IDF will come down. That is one particular reason why we delete all, we do not text normalization and other stuff, and remove all this kind of stop words or the or the slang words or whatever the words we don't want to process, and we give more importance to the important words. So the important, yeah, the TF-IDF, or the term frequency, and the inverse document frequency is all about vectorization, that which is a process of converting this word into the numerical format, and then again study how they are interrelated to each other. Okay. Okay. Now let's see how speech recognition gets affected now. Now, speech recognition, exactly what happens is this is a process where we get the audio input. And this audio input consists of a complex vocabulary, much complex than what kind of vocabulary we get in the written format or the textual format while dealing with documents or the classical enterprise documents. So it needs the whole, now we can understand the, since we got the complexity of those things, this will particularly need separation of tasks. Now, separation of tasks kind of was not very well possible in classical NLP. Classical NLP was all dealing about rules, how these terms were related with this, all those linguistic rules that the expert was framing for this, and every step this expert was needed. And to reduce human defect, we are smart enough to deal with to design the entire process with as a single step, and the separation of tasks was virtually not possible, in fact. So we got in the deep learning aspect. The particular kind of networks that are used in speech recognition, or what we call it convolutional neural networks. So what exactly happens in convolutional networks and how they are related to this separation of tasks is very simple, in fact. So what exactly happens is each layer deals with different aspects of this process of speech recognition, and what exactly happens is each layer gets convoluted to the another one, and this set of layers is now again pooled to the another set of layers, and then it can be again there can be n number of such layers which are getting pooled, and we get a fully connected neural network, in fact. So it brings a very large scale to the entire process of speech recognition. imagine the kind of if we let's say we take some library here which was traditional, or we take a rule-based NLP of all those if-then else statements and all kind of decision engines and stuff, and we try to recognize the sitting there in our server rooms trying to understand what kind of data the our virtual assistants through, let's say, our mobile phones or speakers are sending. In fact, this is a huge volume, and in fact, for companies like Microsoft or Google or this kind of thing, this is a huge task. So we just need a deep learning. This traditional kind of networks won't work. So these models are particularly useful in signal processing or detecting the photonics or kind of word recognition. For example, word recognition is very important as in the speech recognition, because what exactly happens is we don't detect the particular word correctly by different speakers, the whole representation of this word changes. And as we saw, the NLP and DLP with the deep learning is very much particularly based on feature extraction, or the kind of algorithms like word to vector or talk to vector, or this kind of models which are pre-built. And if they don't get the correct input, they are all going to fail. That is for sure. So, in fact, deep learning neural net or the deep learning algorithms, or what we call as the neural networks for short, are capable of correcting this particular mistakes by their own. For example, what we frequently heard, like forward propagation or the back propagation, and how we deal with this back propagation exactly. So what is this back propagation exactly? In short, it's all about the weight different kind of weights attached to the different layers of this neural network. So if we go back, we saw it is one particular layer is one particular set of or the neuron. What we say is all about layers. There are n number of layers here, and these all which are convoluted over each other. And what exactly happens is these layers carry a weight. Now, when we attach it or pull it to the different layer, second layer, some kind of effect of all these weights goes to the second layer or the second set of layers. So if it travels backward, we say it is backward propagation. If it travels forward, we say it as a forward propagation. So what the point I was trying to make was, these are all self-correcting. These no, as the classical machine learning was there. These are all self-correcting and are able to take decisions on their own. This is one other example of this time series content analysis here. So time series content analysis here, as we see in this particular example, is trying to analyze the live comments that are coming in on different videos of a channel. So here if we take it as one part of it, this particular is talking only about one particular video here. So what exactly happens is a particular video comments comes in on the video, and we analyze it in a time series analysis. So what exactly is this time series here? What we are talking about is all about the time-based data, the real-time time-based data. For example, each post has got a date and time for posting. So this we need to record it in real time. So therefore, all this name this time series content analysis. In fact, so if we move ahead, we then again in step 3 we have a extract based basis of cheat detection. What is here exactly in mathematical terms or in computer terms is there is a model sitting out there in step 3, which is consuming this time series, which is already pre-processed in the time series analysis, and we are again feeding with unfair comment data, which was previously there, and then the system tries to judge it based upon this particular model which is sitting there in step 3. This is not as easy as possible as it may seem, because this is only we are talking of one user or one video. In fact, for some sites like you kind of YouTube, let's say, it becomes a whole mess, and it's very difficult for traditional machine learning algorithms to detect all these things. So this is what this particular slide is trying to explain here in terms of time series content analysis. Just like we see here, what we are is as in a typical machine learning in a process, there is a training phase, then we have a test phase. All these things are present, in fact, in deep learning as well, or with the deep learning for NLP. Then there are a couple of other examples here. In fact, like document summarization, as we are talking of the documents. Then, in fact, there is a thing called sentiment analysis. What we all do here for one particular user, we take particular or a particular term here and then try and analyze it. So in practice, that doesn't really happen. The content teams in all these newsrooms, sitting there in newsroom, analyze all this, or they're back in the back offices of different products. They all take this particular data in real time, which is particularly huge and comes from a variety of sources. This all particularly changes. This is a different aspect, in fact, in terms of deep learning. Then there is a machine-to-machine translation. In fact, what we were talking about, like word embedded, vector to vector, word to vector, or vector to or talk to vector kind of things to just to get vectorized data. Then there is captioning of product images on e-commerce sites like Amazon or something like that. And another thing that has brought in is question and answer type of things. So for what is in common language called as natural language queries. So these are typically used in virtual assistants, which are all everywhere. In fact, right from your mobiles to your speakers to cars and everywhere. So you want me to go directly for a demo, or you have some particular questions for me to answer? How you want it? Okay, we'll just go through a couple of demos here, in fact, which I have just pulled out from the Azure machine learning gallery here. They have it on that portal. So this is kind of a BBC news classifier. What it's doing is it has got a data set of full set of data set of news they have collected it from 2004 to 2005 in particularly 5 typical areas, which needs to be classified as business, entertainment, or politics and sports and tech or whatever they are. They are all pre-processed now. We got a CSV there, and which was fed to here, and we got fed to it to produce a data set. We'll particularly now focus exactly on how this kind of processing can be done in machine learning studio of Azure to a designer. So let's go ahead, and here we go. It's bringing in some old version of Azure, so nothing to worry about it. Newer one has all kind of features that we are seeing here. This is this particular example again is a peculiar example of TF-IDF. In fact, in early days of machine learning, we used to do all this type of TF-IDF things. TF-IDF, in fact, very good for understanding the whole process. Just wait, it's taking time. Okay, here we go. Oh, so here's the data set that they are all talking about. The BBC News data set. In fact, it's all pre-processed. If we have a look at it, we can downloading. In fact, we just move ahead. They select the particular columns here, and they edit the metadata. They clean all this missing data kind of things here. What is known as data preparation, in fact. Then they go ahead and select go for a feature selection here, wherein we select what columns we want to process. Then this particular data is split here. This is a very old version. Then we here have our magician's hat here. In this case, it's multi-neural network. So it's the multi-class neural network. Multi-class neural network is all about neural networks dealing with multivariate data. So nothing to worry about it. Then we tune different hyperparameters here. Then again, it goes on to score the model, evaluate the model. We kind of get the different classifications and stuff like that. So let's see if we have some of this business BBC ready here. Okay. Okay. This is the news. This is the category as we are able to see it here. The huge database. In fact. So now here we come on to the tech category. This is what they want the classification for. So as we can see, Here in select data set, they got a they selected the news and the category columns and ignored the uh, serial numbers of the news items. Then they said we will not change any kind of metadata. Here we ask the
Hey, Ashish,
correct.
I
Hello.
think hi, I think your screen is stuck again on, you need to change your screen share option. It's stuck on the PowerPoint slide.
Oh, okay. Now it's visible.
Not yet.
Okay, should be all right now. Okay, what I was trying to do is we just went to this data set what they had in this.
No, Ashish, I still see the PowerPoint screen.
Okay. Just go back and share a new one. Oh, now it's visible.
Yes, thank you so much.
Yeah, I'm sorry about it. Okay. So the particular data set I was talking about that which was downloaded from the site. So as we can see, there is a serial number here. So we have a news and we have a category column here, which we are trying to recategorize for the newer items. So this is business, then politics, sports, and tech also is there somewhere down. As far as this particular, we come back to the design mode. In the second step, where here the first step, obviously we selected the data set here, what kind of data set it is. Then we selected the data, what kind of columns we have in here. We have a column name selected as news and category. Then we said we try to edit the metadata here, asking it to keep all those things unchanged. Here we have an opportunity basically to change the data type, whether it's categorical or which kind of data type it is. We have really missed it by nature. So that's what is trying to make it uniform. So we have asked it to keep it unchanged. Then when it comes to the cleansing data here, what we are trying to do is we are asking it to look for any kind of missing value and then remove the entire row completely. So this is just to simplify it. I think very specific about it, and how we do it is all about this R script here. We don't have to worry about it. For curiosity, if we have, we can just quickly go through this R scripts here as well. So yeah, what we are saying is minimum word length, what it should have, what kind of maximum words it should have, what date, what column we need to process here, and next what it is doing is they're trying to get the document frequency out here through TF-IDF, what we were discussing right now, and then the magic happens, and all we get is the filter database here in this particular step, and we try and select this feature to be processed, and that is all about the label column. That is the category column what we are trying to do. Okay. Then we split this particular data into two, and we bringing the beauty here. What was our magic hat here? The multi-class neural network, which is again fed with all these data here, while tuning the hyperparameters. The hyperparameter for now is all about some kind of parameters that affect the working of this neural network. Nothing to worry about for now. Then we go for a regular score model. Then we evaluate this particular model. And these hyperparameters are here all about how the different layers are connected to each other, or the set of layers is con- connected to the another set of layers ahead. So what we are here saying is just we want 5 kind of runs here at a random speed, and please measure the performance or decide the performance via absolute mean absolute error. This is obviously for, so all again we can see is classification processes as such the same. What is changing is this particular thing. We are bringing in the neural network kind of thing. Otherwise, what we could have done is the split data, some kind of an machine learning algorithm here, nothing to tune about, nothing to do about, nothing to worry about what kind of networks they are, how many runs we want to go through it, nothing. So this is how it changes. In fact, if we run this particular the older version of it, and it's quite funny. That run one. Oh, here we have it. And we run it. Possibly it has completed the selection of the columns here, the data. This is the magic I was trying to talk about. This magic of layers. Everything is models. There's no one single model, one single algorithm. Each layer can, you have the choice. Each layer can of this entire deep learning neural network can have different algorithm, the different way of processing it, and that is how different types of neural networks are formed. So in this case, we here it was TF-IDF, TF-IDF. We got some model here to clean the missing data or the process the data here, to try and understand what kind of frequency this particular data occurs in, how many documents and all these things. It has finished since it was just a small single Excel file here. It quickly. Otherwise, only the drawback of both the deep learning networks and the machine learning networks from classical models of NLP is they take time to process. But the deep learning networks can take very long time than the machine learning, the classical machine learning. Otherwise, this particular process remains safe. What exactly we do here, the volume and the variety, both in both parts. In fact, we process the data as well, and the kind of data we process. In fact, they have messed up one thing like the text normalization module here somewhere here. Whether we there we can take some modern algorithms like keyboards, what you might have heard about, and what's the buzz all going about is the algorithm, GPT model that they use in OpenAI to get also to get okay, the reinforced learning I was talking about. I think it has finished this thing. Okay. You can just in normal as in normal case you can have a look at this output log, get all those data processed, things like that. You can evaluate this particular model, see what kind of output it has generated. This being a older version of Azure, we are seeing this testing. Otherwise, we could have seen the evaluation result. You can ask it to visualize it here. It has got a prediction accuracy. It has calculated. There is a confusion matrix as we see in classical machine learning thing. A bit complex because there are five categories to be predicted. But in class we just saw two of them, but there here are five. Not the process changes. In fact, everything remains the same. In fact, we can see the scores as well here. Kind of statistics, visualization. For this labeled column, we can see different statistics. Unique values 5, missing value 0, because we already had deleted those rows there. There is a histogram here. Okay. So everyone clear about this thing, or we want to go have any questions or want to go much deeper into this particular exam? Okay, let's take the another one, a bit more complex than this one. It's a sentiment analysis, but again via multi-class class text classification. But now we have more simpler neural network called as artificial CNN and combination of the decision tree here via boosting mechanism. So much more complex here. Because the data set is very similar. Nothing much fancy to view fancy here. Look the similar one. There are feedbacks here. There are feedback comments here. What kind of this is the kind of sentiment that we have generated for our training data. Metadata is edited, group categorical values are grouped here. For example, the user feedback. Then we kind of process this particular text. What we are trying to do is here is trying to normalize this data. Then again here we process, try to remove all those what we don't want and things like that. Then we get all this data into three different variables here. These things here are to deal with the inconsistency of the data, the storm type, what we call it. Then we combine that two columns, that's feedback and the sentiment one, get it into one. Now again try to get split everything and try to get the vectorized model. We are trying to get the n-gram model. Quite interesting. Then again we split this, select this particular columns, we train this column via multi-class neural network. Then we have a multi-class decision jungle. Then again the traditional kind of machine learning here. We get a score, we get from two different branches, we combine it, we evaluate it, we get the output for two different columns here. Why? Because it was a multi-class selection, a multi-class classification, which was coming. So that was the third thing. Coming to the third one, I'll just quickly rush through it because we already have passed the time. Okay, this one is another interesting one. Let's skip this one, the text mining one. This is very interesting because here what we are trying to do is identify the speaker via NLP. So voice recognition. This was all about n-grams. In fact, we all didn't have any particular doubts here about n-gram, and skip this one. Okay, here we have the list of speakers. This is another way of visualizing this. As we see, is everything is numbers. So it's already vectorized to some extent now. So we clean the missing data here, then we get a two-class neural network. Two-class meaning there is there are two classes to be predicted out there or to be out of. Then here we split this particular data in as we do it in for any typical machine learning process. We train it, we get the score, and we evaluate it. So very simple in fact. But the real beauty is this all about this two-class neural networks. And as you may see here, we have 150 different modes. Quite a large, in fact, when it comes to the typical machine learning algorithm or the classical machine learning algorithm. As we can see it, as with the typical classical machine learning algorithms, we have a learning rate there, we have a learning iteration, number of iterations we want on each layer. Then we have what kind of normalizer we can have. We can have a Gaussian one as well. Gaussian meaning it's all about probability. So if we run it, we get a typical score, typical model, and typical identification. Just like the normal neural networks. Sorry, the normal machine learning algorithms. So that's all I had from my side. If you have any questions, you can just put it down on my Slack channel here, or you, or in the chat box as well. I can, so that I can pick, or you can just unmute yourself and ask me anything. Okay, Python and Keras, they have their own APIs. For example, the only thing is method can change here. If you just ping me on my Slack, I will give you the link to the code, so that you can check it out. So Keras, so only API will change, nothing much will change. The syntax will change. Everything, the process as such will remain the same here in Python as well. What we'll do is we'll ask the Python to load the data, CSV data, into a data frame. In case of R, we had data set. Here we will have a data frame there. We'll get it, or ask the data frame to select the columns, and then again process, ask it, go through the TF-IDF process and process it. Anything more you have?
और दोनों एक्टर पहले जाएंगे हर्ष और जय। ये याद रखना, जितने फेरबदल वाले हैं उनमें से कोई एक आज अपने घर वापस जाएगा। तैयार है दोनों? हाँ सर। माइंड ब्लॉइंग। हाँ।
स्ट्रॉन्ग है और ये मच्छी पकड़ने का काम करने वाले हैं। क्या है कि हम लोग ने ऐसे सोचा कि शादी के बाद भी जो इधर उधर ये लोग करने वाले काम करते हैं, वो ये काम तो बहुत अच्छी तरह से पकड़ लेते हैं, क्योंकि वो उनका मकसद ही रहता है कि कैसे भी करके वो मच्छी पकड़े, कैसे भी काटने वाली हो, कैसी भी हो, उनको मिले। तो वो यकीन है कि जैसे ये लड़कियों को फंसाने की कोशिश करता है, वैसे ये मच्छी को भी फंसाने की पूरी कोशिश करेगा। जी, सारी मच्छियां फंसा दूंगा मैं। क्योंकि ऐसा ना हो कहीं कि घर जाना पड़े।
Okay. We're just closing, and I think you don't have anything specific. If you have specific, my LinkedIn is also available for you, and the Slack channel is also there. You can pick up my email IDs if you want it. Real, thank you.